So we're looking at lesson 1-4 from the textbook, and I just want to make sure we understand that the most common functions we're going to be dealing with and are the linear functions, the absolute value functions, the square root functions, the quadratic functions, the cubic functions, and the rational functions. And what I have here is the parent function in each case. Notice the parent function for the linear function is just the line f of x equals x. Parent function for the absolute value function, f of x equals the absolute value of x. Parent graph for the square root function, f of x equals the square root of x. Quadratic function, f of x equals x squared. Cubic function, f of x equals x cubed, and the rational function, f of x equals 1 over x. And it's important to be familiar with these basic shapes, because the basic shapes aren't going to change for these types of functions. The only thing that's going to change are going to be they're going to be shifted vertically or shifted horizontally or both, or maybe those are the rigid transform. Oh, and they could also be reflected over the x-axis or reflected over the y-axis. Those are the rigid transformations where the shape is not going to change. There's just going to be a shifting or a flipping, but it stays the same shape. And there can also be non-rigid transformations where a multiplier will, for example, on the parabola, having a multiplier here in front of the x squared, say a 3, would make this grow quicker. It's still going to be a parabola, but it gets skinnier. Or if it was 1/3, still going to be a parabola, but it would be fatter. So that would be a non-rigid transformation because it does change the shape, but it doesn't change the fact that it's a parabola. You're still going to have the same basic parabola for any quadratic. You're going to have this basic shape for any square root function. Obviously, any line is going to be, any variation on that is still going to be a line, and so forth. So it's important to be familiar with these basic shapes. And then once you're familiar with the basic shapes, we need to look at how certain elements are going to change the graph. In other words, vertical and horizontal shifts are one thing that can occur. Now, if your function is another function with a constant added on, then that's going to cause a vertical shift. For example, if we took this very same function right here and we just added 10 to it, then this parabola would stay just like it is, and the whole thing would just move up 10 units. So our function is f of x, but if we had a new function, h of x, that was f of x plus a constant, or in our case, x squared plus 10, that function would just be shifted up 10 units. In a similar fashion, if the constant is subtracted, it's going to cause a shift downward. So any one of these functions, other things being equal, if you have a minus 2 on the end of it, they're going to drop down 2 units. Drop down 2 units. Okay. Now, if you've got a situation like this is going to cause a horizontal shift. And it's kind of just the opposite of what you might expect. If this says minus c, that's going to be a shift of c units to the right. And this is also going to be a horizontal shift, but it's going to be a shift of c units to the left. So, for example, if you had, let's suppose you had a function h of x is equal to the square root of x minus 2, then it's going to be this same function except it's going to be shifted to the right 2 units. So this same function just slid to the right 2 units is what you would get, okay? So, to summarize vertical and horizontal shifts, this is what explains vertical and horizontal shifts of any function. Now, you can also have reflections. So, for example, this parabola could be turned down like this. Instead of it opening up like this, it could open up and go down. That would be a reflection over the x-axis. And what causes reflections over the x-axis, or what you would look for to see if that's what was going on, would be that your function is the negative of the other function. So, for example, in this case, suppose we had h of x was negative x squared. Notice that's the negative of this function. In other words, h of x is the negative of f of x. That causes a reflection over the x-axis. So instead of looking like that, it would actually be turned over this way. In a very similar fashion, if you have h of x is equal to f of negative x, if it's as if a negative x has been substituted into the function, that's going to cause a reflection over the y-axis. That's going to cause a reflection over the y-axis. So, for example, in the square root function, let's suppose h of x was the square root of negative x. In other words, h of x is the same as f of negative x. If you plug negative x in here, you would have the square root of negative x. So what that's going to cause is a reflection this way. So instead of going here, it would be going like this. And so those are all of the possibilities for a rigid transformation. You know, sliding sideways, or sliding up and down, or reflecting over one of the axes. Non-rigid transformations are going to come in where, say for instance on this one, which I think we mentioned just a few minutes ago, we had a multiplier, we call this h of x. We had a multiplier here other than 1. It's obviously got a 1 now, but let's say it was 5. Then, you know, if we were to put 1 into this function, in other words, f of 1, you would get 1. In other words, the ordered pair 1, 1. If you were to put 1 into this function, you're going to get 5. So you get 1, 5. Basically, because this 5 is here, this one is going to be growing much faster, and it's going to make it look more like this. Let me do it in a different color here. It's going to make it look more like this green one. In other words, it's going to be skinnier, because instead of 1, 1, there's going to be a 1, 5. It's growing faster, so it makes it skinnier. And by the same token, if this was a 1/2 here, or a 1/3, or something like that, it would actually go, you know, it would get a lot fatter like this. So again, that would be a non-rigid transformation because it is changing the shape, although it is still a parabola. Now let's look at just a couple of examples here. Suppose we had h of x is equal to x cubed plus 5. And we wanted to sketch the graph of this. Then, of course, we need a coordinate system. And I just want you to notice that, of course, we know what x cubed would look like. And maybe we'll go ahead and put some marks in here. You know, if f of x is x cubed, that's the parent function. We know what it's going to look like. If you were to put in 0, you would get 0. So it's going to go right through here. If you were to put in 1, you're going to get 1. So it would go through here. If you were to put in negative 1, you're going to get negative 1. So it would go through right here. And then other than that, it's going to grow pretty quickly. Actually, probably kind of be a little more like this. So here's our parent function, x squared. I'm sorry, x cubed. But in red, I'm going to do x cubed plus 5. What that tells me is it's going to shift up. That's this case here. It's going to shift up 5 units. Every point on this is going to go 5 units higher, which is the same as saying the whole thing just slides up 5 units. So this point that was here at 1, 1, it's going to be 5 higher than that now. It's going to be not at 1, but at 6. So it's going to go way up there like this. This point that was at 0, 0 is now going to be up here at 0, 5. This point that was at negative 1, negative 1 is now going to be at negative 1, 4. Like so. And then we're going to have our parabola coming there, not parabola, our cubic coming there like that. So, again, the point being, if you took this one and just shifted straight up 5 units, that's what you would get. So, knowing what the basic shape is, knowing the parent function is that cubic, and then knowing that we're adding 5, just going to shift it up 5 is nice. Another example, let's suppose we had, and we'll work with that same parent function, but suppose we had h of x is x minus 3 cubed plus 2. Then, once again, we have our parent function, this cubic function. But this one is going to actually have 2 shifts going on. It's going to have a vertical shift of 2 units, but it's also going to shift to the right 3 units. That means every point on this is going to go right 3 and up 2. So let's say this point, for example, it's going to go 3 to the right and up 2. That's going to be its new spot. This one is going to go 3 to the right and up 2. This one is going to go 3 to the right and up 2. This one, 3 to the right and up 2. Every one is going to do the same thing. And so we're going to have, something like this. Every point on the blue one went 3 to the right and 2 up. And again, we can see that it was a combination of 2 of these things. We had a constant added on, but we also had a horizontal shift to the right. So it took that cubic and it slid it to the right, and then it slid it up, and that's what we ended up with. Now, the last examples to look at are going to be, suppose we had the function, this function right here. And we wanted to compare how it would look with this one. Just in words, what would the difference be? Well, the graph of this, notice this is the negative of f of x. Because f of x is the square root of x minus 1. This is the negative of that. So g of x is the negative of f of x. That's a reflection over the x-axis. So the graph of this reflected over the x-axis is what this one would look like. And let's also consider h of x, which is the square root of negative x minus 1. We'll see what's going to happen, and we're comparing with f of x here. This is the one we're comparing to. We saw what happened with g of x, reflection over the x-axis. What's going to happen here? Well, if you think about it, if you were to input a negative x here, you would get the square root of negative x minus 1, which is what we have here. In other words, h of x is the same as f of negative x. This is going to be a reflection over the y-axis. So the graph of this reflected over the y-axis will give you the graph of this. So that's the heart of what we needed to get out of this lesson 1.4, just to understand that these functions with these familiar shapes, how are they affected graphically by adding certain elements in, like adding a constant and things of that nature. And this is a pretty good summary of the things how the graph is going to move around based on those factors. You've got your vertical and horizontal shifts, and you've got your reflections. And then, of course, we talked also about the non-rigid transformations where you've got multipliers that will stretch or shrink a graph. And that pretty well summarizes what we need from lesson 1.4.